right, so now I feel silly because I went and made a correction, and then I said it and wrote it wrong. I was looking back at this one here, and the whole point was that this now rounds down when that's 5.535, so the force exerted by gravity is 5.5 times 10 to the third newtons. So you want to go back and take a look at that. All right, so now we're going to look at this one. We have a ball that's coming in 45 meters per second right here, like this. It leaves 45 meters per second here. So taking the difference between those two, we can see that the only difference, this is V naught and this is V final. We can see that the only difference between them, since they have the same x component, is the change in the y component, which is what they say right here. Only the vertical component of the ball's momentum changes. All right, so what is the initial y component? If we take downward to be negative, that's not a very well drawn vector there. If we take the, oh my goodness, we take the y component to be, the initial y component to be negative, all right, that is going to be equal to 45 meters per second times, if this is 30 right here, times cosine 30 degrees, okay? So, and then when we go back up this way, this is going to be equal to 45 cosine positive. 45 cosine 30 positive. Wow, messing this up. 45 cosine 30, that's going to be positive, and here it's going to be negative. All right, so that's conceptually what we're going to be doing. So I'm just going to plug it in with some algebra. We'll run it algebraically first. We got a mass, and we got that speed, 0.047 kilograms. All right, so we know that the magnitude of the impulse, all right, is going to just be about the change in momentum. Impulse is equal to change in momentum, delta P. All right, is equal to delta mv is equal to m times delta v. All right, so impulse is going to be equal to the mass of the ball, 0.047 kilograms, 0.047 kilograms, times the difference between, times delta v, which would be the initial velocity, or the final velocity minus the initial velocity. All right, so the final velocity is positive 45 cosine 30 minus negative 45 cosine 30. Plan ahead. All right. So knowing that, that's going to be equal to J is equal to 0.047 kilograms times 2 times 45 cosine 30. And I got 3 closes to do there. Okay? Because we got, here's plus 1 and here's plus, minus a negative, so we get this twice, right? So we have J is equal to, crunching numbers here, we get 3.66 or 3.7. Looks like everything's 2 sig figs. This is 45 meters per second up here, so we get kilogram meters per second. All right, there would be some purists who would say that impulse is given in Newton meters. So we would say that J is equal to 3.7, I'm sorry, not Newton meters, Newton seconds. So either one of these answers would be acceptable because if we take newtons, it's just as true. If we take newtons and break it up into kilogram meters per second, we would end up with kilogram meters per second. Let's see, newtons is kilogram meters per second squared times seconds gives us kilogram meters per second. Full dimensional analysis.